Hi, hello dear students, welcome to our channel Maths with Panindra. In this video, we are going to discuss about the point of concurrencies. In that, we are in the third concept. In the last video, we discussed about centroid and orthocenter. Now we are going to discuss about circumcenter and the properties. In that, few important results also I am going to discuss here. First of all, what is the definition of circumcenter? The point of intersection of perpendicular bisectors of the sides of the triangle is called circumcenter. It is denoted by S. See how it is in the figure. So this is the triangle ABC. In this triangle ABC, AB, BC, CA are the sides. Perpendicular bisectors point of intersection. So perpendicular bisector of BC side, D is the midpoint. So the line which is perpendicular to the side BC and passing through the midpoint of this side, this is perpendicular bisector of side BC. Similarly, you join like this one. For the side AC, E is the midpoint and perpendicular bisector of side AC is, for the side AB, F is the midpoint and it is perpendicular bisector of side AB. The point of intersection of these perpendicular bisectors is called circumcenter. It is denoted by S. This is the meeting point. And one more important result from this, the circumcenter S of the triangle ABC is equidistant from vertices of a triangle. That means from S to A, from S to B, from S to C. That means SA is equal to SB equal to SC. The circumcenter S is equidistant from the vertices of a triangle. Then we have SA equal to SB equal to SC. Now come to the third point, important point regarding this. The circle passing through the vertices of a triangle is called circumcircle. Is called circumcircle. See how it will be. The circle passing through vertices of a triangle is called circumcircle. The circle passing through the vertices of a triangle is called circumcircle and whose radius is called circumradius. So from S to A, from S to B, from S to C, these are called radius. This radius is called circumradius and it is denoted by capital R. So SA radius is always equal only, no, from here to here distance, from here to here distance, from here to here distance. So SA equal to SB equal to SC is equal to capital R. It is called circumradius. Regarding circumcenter, three important points based on that we will discuss. The circumcenter of a right angled triangle is the midpoint of hypotenuse. Sir, how will say that? Circumcenter of the triangle, right angled triangle, is midpoint. The figure will come like this. This is the triangle, right angled triangle. So here A, B, C. So what is the hypotenuse here according to the figure? BC is the hypotenuse. So midpoint of BC I am taking as S. That is called circumcenter. The circumcenter of right angled triangle, whether it is at A or B according to this figure, right angle at A. So for right angle triangle, the circumcenter is always midpoint of the hypotenuse. For example, A I am taking 0, 0, origin, A position I am taking as 0, 0. B point I am taking as 0, 6. Sorry, 6, 0. So B point I am taking 6, 0. That means it is at a distance of 6 units. Indirectly it is x-axis AB. C point I am taking 0, 6. C point I am taking as 0, 6. 1 minute. See here, whether it forms rectangle or not, we will check that. 0, 0, 6, 0. Distance between them is, it is these two are, anyway A is the origin. So from origin to the point, it is right side. So at a distance of 6 units. So from here to here 6. Even from origin to the towards upward, that means here also 6 units are there. Why? Because it's a y-axis, we are assuming on y-axis x coordinate is 0. So 6 units. So here 6, here 6. So Pythagoras theorem, whether it is applicable or not. 6 square plus 6 square is 36 plus 36 is 72. So BC value 6 by 0 whole square, 36 plus 36 72. Under root of 72 square means BC square is equal to 72. So it is satisfying Pythagoras theorem, means it is a right angle triangle. For right angle triangle, circumcenter is what? Midpoint of hypotenuse. Midpoint formula x1 plus x2 by 2, y1 plus y2 by 2. 6 plus 0 by 2. 6 plus 0 by 2. So ultimately this is 3, 3. So circumcenter of the right angle triangle is 3, 3 for this question. Now come to, for acute angle triangle, circumcenter lies inside the triangle. So how you are saying that inside only, why can't outside? The discussion will be there. So observe that carefully. This is the acute angle triangle. Observe here, less than 90, less than 90, less than 90. Acute angle triangle. What is the definition of circumcenter? Point of intersection of perpendicular bisectors. So for this side bisector is here, this one. For this side bisector is this one. For this side bisector is this one. Anyway, for acute angle triangle is point of intersection of perpendicular bisector is what? Circumcenter. For acute angle triangle, circumcenter is lies inside the triangle. Observe carefully, dear students. Now come to obtuse angle triangle. For observe this figure. This is obtuse angle triangle. Why? Because here angle is more than 90. So this is a triangle ABC. Even here also you can take this ABC. Obtuse angle triangle. So for this side BC, D is the midpoint. This is perpendicular bisector. For this side AC, this is the midpoint. Perpendicular bisector will be here. This is the perpendicular bisector of side AC. Perpendicular bisector side AB. This is the midpoint. So perpendicular side. So which are meeting at this point. Whether this point of intersection of perpendicular bisectors is what? Circumcenter. It is denoted by S. For this obtuse angle triangle, it is more than 90 degrees. For this obtuse angle triangle, the circumcenter is outside the triangle. Observe carefully. Outside of BC it is there. So for the acute angle triangle, lies inside the triangle. For obtuse angle triangle, circumcenter lies outside the triangle. This is the example. I hope everyone understand that. For obtuse angle triangle, the circumcenter is outside. For acute angle triangle, the circumcenter lies inside. For the right angle triangle, the midpoint of the hypotenuse. Why we are stressing on this concept? So match the following questions are there, no? They will give these concepts in list 1. Answers in the list 2, you have to match. Like this way, they may chances to ask the students. You remember, nowadays online examinations, no. So creativity in these chances are there. Even this concept also, circumradius and circumcenter is equidistant from the vertices of a triangle. These concepts also they will make as a like list 1, list 2 match the following questions. Now come to one shortcut formula regarding circumcenter when the points are in this form only. When the points are in this form, what is the shortcut formula? So the circumcenter of the triangle formed by 0, 0, x1, y1 and x2, y2 is. That means among the points, one of the vertex is origin. So one of the vertex is origin and the rest of the points are x1, y1, x2, y2. The circumcenter is defined as y2 into sum of the squares of first point minus y1 into sum of the squares of second point by 2 into x1 y2 minus y1 x2 or x2 y1. Similarly, wherever y2 y1 is there, x2 y1 you can write it x2 x1 and sum of the squares of first point, sum of the squares of second point. But the thing is, denominator will be interchanged here. The term 2 into x2 y1 minus x1 y2. This is the thing you have to remember, dear students. We'll take one example. When the points are, so find the circumcenter of the triangle 0, 0, 1, minus 2 and 2, minus 3. Like this I am taking. So find the circumcenter of the points. So apply directly in the formula. y2. What is y2? y2 is minus 3 into x1 square plus y1 square. 1 plus 2 square, that means 4. Sorry, 5. 1 square plus 4, 5. Minus y1. y1 value is minus 2 into x2 square plus y2 square. 4 plus 9, 13. Divided by 2 times of x1 y2. x1 y2. So minus 3 x1 y2. 1 into minus 3 minus x2 y1. x2 y1. x2 y1. So 2 into minus 2. So plus 4. Comma. x2 value is what? x2 value is 2 into x1 square plus y1 square. Again we are getting the same 5 minus x1. x1 value is what? 1 into x2 square plus y2 square. 13 by 2 into, interchange these places, 4 minus 3 only, x2 y1 minus x1 y2. That is equal to minus 15. Minus into minus is plus 26. 13 2s are by 4 minus 3 is 1. 1 into 2. 10 minus 13 divided by 4 minus 3 is 1. 1 into 2 is 2. So sorry here. x2 y1 means 4 minus x1 y2 is minus 3 means plus 7 will come now. Sorry. 7. x2 y1 value is x2 y1. x2 means 2, y1 means minus 2. So x2 y1 minus 4. So here minus 2 will be. Next minus x1 y2. x1 y2. So 1 into minus 3. Minus of minus 3 plus 3. So which is equal to 26 minus 15 is 11 by 2. 10 minus 13 minus 3 by 2. Minus 3 by minus 2 is 3 by 2. So I hope you understand that. This is the way you have to remember shortcut formula. The next concept is in-center. After that, x-centers. In-center concept we are going to explain. I hope everyone understands. Still any doubts are there? After completing of these videos, I will give that examples, different models I will explain. Now we are going to discuss about in-center. What is meant by in-center? The internal angular bisectors of triangle are concurrent and the point of concurrency is called in-center. The point of concurrency is called in-center and it is denoted by capital I. Observe the figure here. In triangle ABC, this is internal bisector, internal angular bisector. So here angle is A by 2, here angle is A by 2, total it is A by 2 plus A is angle A. So this is also internal angular bisector of B, internal angular bisector of C. So the point of intersection of internal angular bisectors is called in-center. It is denoted by I of x comma y. So one important point regarding this in-center is at an equal distance from all the three sides of the triangle. So that means in-center is IM IN, ID, all these values are equal. In center is not from the vertices, dear students. You remember that? In center is equal distance from all the sides of the triangle. That means IN, ID, IM from the figure. These values are equal. This is regarding distance. In center is equal distance from all the sides of the triangle. Next come to important point. This result while solving in properties of triangles or any geometrical problems which involved in that, we will use this concept. See, in triangle ABC, if the internal bisector of A, this is internal bisector of A, meets BC at the point D, then BD is to DC is equal to AB is to AC. So BD is to DC, these two distances, BD is to DC is equal to AB is to AC. Remember that. So very important point. The internal angular bisector of A meets the side BC at the point D, then BD is to DC is equal to AB is to AC. So see, remember, this is very important point. Now come to another important point. This is if I is an incenter of triangle ABC, then AI is to ID is equal to AI is to ID is equal to AB plus AC is to BC. So sum of these two sides is to the other side BC. AB is to AC, AB plus AC is to BC. Suppose if it is from B, I is intersection of B, then here BI is to IM can be written as similarly from this. BI is to IM is equal to, how we will write it is through B, no? So BC plus BA or AB is to AC. We can write like this. That means what? BC means small a plus AB means small c. A plus c is to AC means small b. So one more important thing, remember that in center, the distance between capital A and capital B is equal to small c. Distance between capital A and capital C is equal to small b. Distance between capital B and capital C is small c. So the distance between these values we are representing in small. These are the lengths of the sides of the triangle. Now similarly, if and I is the incenter, if it is from C side, so CI is to IN, CI is to IN, that can be, in what ratio it will be divided? CI is to IN is CA plus CB, CA plus CB is to AB. What is CA? CA means small b only, plus CB means small a is to AB means small c. So CI is to IN can be written as A plus B is to C. From this we will get the rest of the terms also. Now in triangle ABC, if A of x1 y1, B of x2 y2 are the vertices of a triangle, C of x3 y3, then and AB equal to C, BC equal to A and CA equal to B, then inside of the triangle is defined as A of x1 y1, AX1 plus BX2 plus CX3 by A plus B plus C, AY1 plus BY2 plus CY3 by A plus B plus C. So how it will come? Just now I discussed now. AI is to ID. D point how it will come? D is the midpoint of BC only, no? So x2 plus x3 by 2. Y2 plus Y3 by 2 will come. A point and B point we know that. So I divides AD in the ratio of AI is to ID only, no? AI is to ID. AI is to ID means in place of M and N, C plus B and A substitute and simplify, you will get this value, dear students. So this is the formula for in center of the triangle. So AX1 plus BX2 plus CX3 by A plus B plus C. X coordinates completely. Come to the Y coordinates. AY1 plus BY2 plus CY3 by A plus B plus C. This is about in center. Here, one more short trick we are going to learn. The incenter of the triangle formed by origin and a comma 0, 0 comma b. So one point lies on the x-axis, one point lies on the y-axis, and one point at origin. That means among the 3 points, one point is at origin and the other 2 points are lying on x-axis and y-axis. That time, how to find the incenter of the triangle? So I of x comma y equal to a into mod b by mod a plus mod b plus root over a square plus b square, comma b into mod a by mod a plus mod b plus root over a square plus b square. This is the shortcut formula, dear students. Keep in mind and practice. So only few problems are there by using shortcut formulas. These shortcut formulas also from regular procedure only it will come. But most of the students, they will feel that shortcuts. Every time shortcuts, it won't work out. Only the general procedure, subject knowledge is very important, dear students. According to my knowledge, I am saying. So, in the next concept, excenter about in the triangle ABC, how it will be. That I am going to explain in that. Thank you. We will move to the next concept. The next concept is excenters. What is meaning of excenter? Excenters. The internal angular bisector of one angle and external angular bisector of other two angles of a triangle are concurrent and the point of concurrence is called excenter. Observe carefully, dear students. Triangle ABC, in that A vertex is x1, y1, B is x2, y2, C is x3, y3. We know that AB is equal to small c, AC is equal to small b, BC is equal to small a, whose lengths. For any triangle, there are 3 excenters opposite to each vertex that I am going to explain now. AB is equal to small c. So, through the vertex A I am taking the internal angular bisector of one angle. So, here A by 2, A by 2. One internal angular bisector and 2 external angular bisectors. 2 other 2 angles of triangle, angular bisectors. External, 1 internal, 2 external. 1 internal angular bisector, 2 external angular bisectors which are intersecting at this point. This point of concurrence is called excenter. The point of intersection is called excenter, opposite to the vertex A. Similarly, from B also you draw one internal bisector like rough figure I am drawing here. And from C and A, external bisectors which are intersecting. So here, this is an internal bisector, and here also like you can intersect this point. This is I2. Similarly, from C also we can take. So somewhere here it will be, it is I3. So how to define the how to give the formula for excenters opposite to the vertex A, opposite to the vertex B, opposite vertex to the C. What is incenter formula? Ax1 plus bx2 plus cx3 by a plus b plus c, ay1 plus by2 plus cy3 by a plus b plus c. If you want to write that formula for the excenter opposite to the vertex A, in this incenter formula, the first term in the both numerator and denominator in x and y coordinates, you can keep that minus. Only the first term, minus ax1 plus bx2 plus cx3 by minus a plus b plus c, minus ay1 plus b by 2 plus cy3 by minus a plus b plus c. Similarly, the excenter opposite to the vertex B, B is the second one. No? So, second term in the formula of incenter, you can keep minus in both in the numerator and denominator as well, x coordinate and y coordinate. Similarly, I3, the excenter opposite to the vertex C, is ax1 plus bx2 minus cx3 by a plus b minus c, ay1 plus by2 minus cy3 by a plus b minus c. After that, one important result. Here I1, here I2, here I3 will come now. I is in center of the triangle. In any triangle, in center I is the orthocenter for triangle formed by I1, I2, I3. For this triangle I1, I2, I3, I is what? I is orthocenter. Keep in mind, this is in objective it may be helper. I in center is the orthocenter for the triangle formed by I1, I2 and I3. So for the triangle, the orthocenter will be in center only. I hope you enjoyed. In the next video, we are going to discuss about 9-point circle. A very important concept, that is 9-point circle. After that, some important results based on medians and missing vertices, some shortcut formulas there we will discuss. After that, different problems based on these videos I will give it, dear students. Thank you. Signing off, Maths with Panindra. Please do subscribe and share to your friends and your relatives or well wishers. Thank you all. Signing off, Maths with Panindra.